Welcome to the deep dive. Today we're zooming in on a specific piece of hardware. It's the DVIGear DVI-2860-AOC Active Optical Cable. And we're using this cable as a kind of masterclass to understand how you get ultra-high-res video across, a massive space.
Exactly. That's the core mission. I mean, if you've got a device pumping out 8K footage or high frame rate 4K, you normally have to keep your display really close.
Right.
Because standard copper cables, even the best ones, they just hit a wall, maybe 15, 20 feet, and the signal starts to degrade.
Due to attenuation, noise, all that stuff.
All of it. And this AOC, this active optical cable, is really the elegant solution that just laughs at those limits.
Okay, so let's unpack the performance. Our sources say this supports DisplayPort 1.4 HBR3. For those who aren't in this space every day, that means an aggregate data rate of, up to 32.4 gigabits per second?
That's right, a staggering 32.4 GBPs.
So what does that kind of speed actually unlock for an engineer on the ground?
It unlocks fidelity and distance at the same time. That data rate allows for resolutions like 4K at 60 Hz with full 4.4.4 color.
Meaning you get all the original color information, no compression.
Exactly, every piece of it. Or, if you care more about raw pixels, you can run 8K resolution at 30 Hz. But here's where it gets really interesting. It can do all of that reliably over distances up to 100 meters.
Wait, 100 meters? That's 328 feet.
Yep.
If I tried to run a traditional copper cable that far, I'd need massive repeaters, and I'd probably still get signal drop.
So what's the trade-off here? Is there any signal degradation with this optical approach?
That's the beauty of it. There isn't. And that's where the hybrid design really comes into play. The video signal isn't traveling over copper at all. It's traveling as light over 4 glass optical fibers. GOF.
And why is light so much better than copper, especially in, say, a crowded data center or a high-security room?
In a word, immunity.
Okay.
When you use fiber for the video, the signal is completely immune to environmental RFI and EMI noise, radio frequency and electromagnetic interference.
Precisely. In an area with lots of machinery or, strict data security needs, that low EMI profile is critical. Fiber just ignores the electrical noise that copper would absolutely pick up.
So the optical fibers handle the sensitive high bandwidth video, but it's called a hybrid cable. It still has copper wires in it. What are the other 6 copper wires doing if they're not carrying the picture?
They handle the essential but lower bandwidth tasks. First is power. The cable itself is ultra-low power. It draws less than half a watt directly from the DisplayPort source, and the copper carries that.
And the second task?
The second is the AUX channel. That's a 1 megabit per second bidirectional line.
And why is that auxiliary channel so vital?
That's the handshake. It's absolutely vital for protocols like EDID.
Which tells the source what kind of display is on the other end.
Right. And for HDCP, the content protection, without that copper carrying the AUX channel, the source and the screen would never even talk to each other. The engineering success here is marrying the speed and immunity of fiber with the essential reliability of copper for power and control.
And that focus on reliability, I saw a spec on mean time between failures.
Oh, yeah. The MTBF is over 150,000 hours. That's, true operational confidence.
Speaking of operations, installation can be the nightmare of a long run. The sources mention a minimum bend radius of just 35 millimeters, and these low-profile mini DisplayPort connectors. That small size has to make a difference when you're pulling cable through a tight conduit.
It makes a huge difference. Those tiny mDP ends, they're less than 8 by 11 millimeters, they make what we call conduit fishing so much easier. But the adaptability is the real time saver. The product comes with these detachable docking connectors.
Okay, so how do those work?
You pull the cable through with that small mDP end, then you just snap on the docking connector, and it converts it into a full-size locking DisplayPort receptacle. You skip needing any bulky, unreliable dongles.
So that fusion speed, distance, and that built-in security from noise interference that really makes this hyperlight AOC tech a benchmark.
Absolutely. It just fundamentally changes what's possible in a complex installation.
Well, as we wrap up, let's leave our listeners with a final thought.
Sure. So think about this. We've talked about the low RFIME profile, but this cable is also engineered with a very high crush resistance. Over 500 newtons.
That's incredibly durable.
It is. So my question for you to consider is, how might this blend of robust optical and copper, this mix of physical durability and perfect signal integrity, influence the next generation of industrial sensors, or maybe high-def medical imaging equipment, far beyond just delivering video? That combination is really the future.